All right, moving on into an additional network component here. Let's take a look at a bridge. So bridges could still be in use somewhere. They are still a little bit older, but let's first of all address what they do. So let's take a look at this graphic over here above my head. First of all, ignore the way it looks right now, and let's just assume instead that instead of all these pieces of equipment here, we had one hub, okay, with all of its little ports in here and everything, okay. We saw that in a previous video here, right? So with this one hub going on, remember, every message that a host sends into that port that it's connected to, that message goes out of all other ports. So it's very, very chatty, and it creates a lot of collisions. This is really just one collision, what we call collision domain, okay? So the more hosts you add on to that, the chattier it gets. And again, it's like being in a really crowded room with everybody talking all at once, and you have to ask people to repeat themselves a lot so that you can hear what they were trying to say. However, if we use a bridge now, and instead what we can do is we can have a hub here, okay, which you see there, another hub over here, and then a bridge right here in the middle. What is this going to do? So first of all, this hub here is now connected to fewer hosts, right? So instead of having one big hub connected to lots of hosts, we have two hubs that are connected to a smaller number of hosts. Let's just assume half the number of hosts each, right? But the problem is host A might still need to communicate with, say, host D over here. So how would that happen? Well, what we can have is a bridge here in the middle, which, by the way, these operate at layer 2. And what it's going to do is it's going to collect MAC address information on both sides of it. So the bridge, usually that's going to be some kind of a computer with physical network adapters in it. Could be a Linux box, could be a Windows box, whatever, all right? So it's usually not a physical piece of hardware that you go down and buy at the electronics store or you order on Amazon or eBay or something, okay? I mean, those exist as well, but most of the time they are software-based. So now what we do is we install this bridge, and it connects to this hub, and this other port on the same bridge connects to this hub, and the bridge will memorize the MAC addresses on both sides of it, okay? So now what happens if host A needs to communicate with, say, host B, then it never goes through the bridge because the bridge will discard it because it recognizes that the MAC address for both host A and host B are on the same collision domain. And then it will say, well, I'm not going to forward that over to collision domain 2, that would just be a waste, right? It just forward traffic unnecessarily. However, if host A does need to communicate with host D over here, then again, the bridge knows the MAC addresses for both sides of this communication, and it will recognize that the destination MAC address is on the other side of the bridge. So in that case, it will forward it down across that bridge. Now, I also will point out that hubs, as well as bridges, generally speaking, they're really only capable of working with networks in the 10/100 speed. So that would be a megabits. Oh, my pen's not writing. Megabits per second. Okay. So that also, again, kind of shows how old these are because almost everything's gigabit-y now. So gigabit speed. So that's just a free bonus information, FYI. So largely nowadays, since bridges operate at layer 2, all right, it's usually better to use a switch instead of a bridge. So again, switches aren't that expensive, especially in a smaller network that are unmanaged switches. So just replace all of this with a bigger switch that can support all these devices, or you can daisy chain two switches together and create this network infrastructure. And each port on that switch is essentially its own collision domain. So that makes collision domains kind of a thing of the past when you use a switch instead. Now, let's also take a look here at how this might look, just to satisfy any curiosity if you want to see how it might look. Let me see. I've got control panel open here, and I'm just going to do this in Windows for right now, but notice that I have several Ethernet adapters right here, and maybe Ethernet 2 was connected to a network on the left. Maybe that would be, something like this network over here. And Ethernet 3 is connected to this network over here. And maybe my Windows machine is this bridge. Okay, so this control panel that we're looking at right here essentially is in the place of that bridge. So what I would do when you create a bridge, you have to select 2 or more network adapters, right? And then I'll just right click there and I'll choose bridge connections. And now what's going to happen is this is going to memorize MAC addresses on both sides of the bridge and only forward what MAC address traffic needs to be forwarded across that bridge. Anything else, it'll just keep on the same side of the bridge and effectively, all things being considered equal here, effectively cut our broadcast domain in half. Whoops, I almost forgot. I left a bullet point out here. Okay, so the bridge also does not require separate subnets like a router. Okay, we'll be talking about routers here coming up shortly. But just for right now, let's just assume that instead of a bridge, this is a router instead. In that case, what we would have here is two separate subnets, and they would have two separate IP addressing schemes. Okay, let me make them kind of drastically different so that it's very obvious. This one might be 10.10.1.0 with a 24-bit subnet mask. Don't be worried about if you don't know what that /24 is or even the IP addressing right now, okay? We'll be talking about that later, but for now, just understand that that's one family of IP addresses, if you will. And then over on this other side, I'll make it drastically different. Maybe we have 192.168.1.0 with a 24-bit subnet mask over there as well. Those are two totally separate IP addressing schemes on two totally separate subnets is what we would call it, okay? So a router would separate these networks and they would also have totally different network identifications, network IDs, okay? Whereas a bridge will use the same network addressing across both sides of this. So maybe we have 10.10.1.0 24-bit subnet mask across both sides of this, okay? That would be the case with a bridge. Thanks for watching. Subscribe here to get the latest from CBT Nuggets. Also, if you're new to IT or are interested in an IT career, visit cbtnuggets.com and sign up for a free trial.